So our problem statement is to get top N daily products based upon the revenue generated by that product on each day. So we already developed the logic to get daily product revenue. So we'll use that and we'll try to improvise on top of it. So the high level steps are, once we get the daily product revenue, we have to import window and create a spec to partition by date and order by revenue in descending order. So revenue is a derived field which is computed while creating this data frame called daily product revenue. Okay, so using that data frame, we'll use window spec and then we partition by the date and then order by revenue in descending order. Once that is done, we will use withColumn and assign the rank. So each and every record will get the rank based upon the date and then the order by revenue in descending order. Once the rank is assigned, we can filter the data. So in this case, we'll be passing topN as the argument, like 3 or 5 or whatever number we want, and we will be using that to filter once the rank is computed, and then we have to drop the rank field because that field is not required to save it into the files. If it is required, you can retain. However, in our case, I don't want to get the rank field, and hence I will be dropping that rank field, and then data will be saved into a file as a JSON or CSV, whatever file format we want to save it. So in this case, I think we are using CSV, so we will try to save it in CSV format itself. That being said, you can come up with the logic in SBT console and then implement in IntelliJ. However, I'm actually directly implementing in IntelliJ itself. So here, daily product revenue is the data frame name. It has multiple fields. One is order date, second one is order item product ID, and third one is revenue. Revenue is the third field. Okay, so first and foremost, we have to import org.apache.spark.sql.expressions. We just need window here. Others are not required unless and until we explicitly want to define the data types. Once that is done, let us create the spec window.partition by. Order date is the field on which we have to partition. Revenue is the field on which we want to sort the data, and we have to sort the data in descending order. So we have to say .desc. Now I can actually say val topN daily products equal to daily product revenue dot with column rank. So in this case, I'm using sparse rank. So rank dot over, because rank is not imported here. It is not recognized. Now it is recognized. Rank dot over and then spec. Once that is done, we can actually say filter rank less than or equal to topN. So topN, we have to define the variable here. So we'll be defining the variable here itself. Val topN args of 1. So arguments are typically of type string. However, we'll be passing integers. So we have to typecast it into integer here. So topN is now of type integer. So we'll be comparing that here. So this is the API which we have to use, less than or equal to. Okay. Once it is filtered, we can actually drop the rank column. We don't need any more. And then we can actually say order by order date and then revenue dot DES. Now we can actually uncomment this. We need this val output base directory equal to whatever path we want to give. And then the variable name should be topN daily products, write.csv, and then give the directory name you want to save this data to. So topN daily products df. Then you can actually save this. You can go to run, edit configurations. There is no application here. Either you can run it directly, let it fail with array index out of bounds exception, and then come back here and adjust, or you can directly add application also. So plus application, the class which you want to execute is nothing but get topN daily products df. It takes 2 arguments. One is dev, and then let's say I want to get 5 top 5. So I can pass 5 here. You have to specify the class module here, Spark demo, and then you can say apply. Okay, right click on it and then run it. So in this case, I have passed as dev because I'm using Windows, and if you look at application.properties, dev is for Windows, devu is for Ubuntu, and devm is for Mac. So that's why I have passed dev here. Now the program is executed successfully. There are no exceptions here. You can go to the file explorer, go to data. Let's see the path. It's C data Scala Spark under Scala Spark topN daily products df, and you can see the 2 CSV files here. You can open it by using probably WordPad or Notepad, whatever it is. I opened it with WordPad, and you can see the results here. We got top 5 products on each day using revenue as criteria. Now we can actually ship this to cluster and run it on the cluster. However, we have to go to Ubuntu, go to the working directory of the project, which is nothing but mount C users dig other idea projects Spark demo. Now we can actually say SBT package and hit enter. It will create a jar file, and you can ship the jar file to the cluster, and you should be able to run it on the cluster. As I have already demonstrated several times, so I'm not going to run it again on the cluster. If you want, you can actually use this command. It takes additional argument. I will fix it, and it will actually take care of running it on the cluster in the yarn mode, and you should be able to see the results based on the path which you have specified as part of your application.properties. So that being said, if you have any questions with respect to window functions or analytic functions or ranking functions that comes as part of org.apache.spark.sql.expressions.window or window spec, let me know. Otherwise, we'll take 10 minutes break and we'll actually catch up after 10 minutes.